Hello friends and welcome. In Python, a list is used to store multiple pieces of data at once. In the previous lessons, all the data types we have encountered could only store a single item. The list data type in Python is considered a sequence because it can contain multiple elements. Simply consider a list as a container capable of holding multiple items. Items within a list are ordered and indexable. This implies that we can reference an element using its index. A list is mutable, enabling us to modify the original list. This is in contrast to a string, which is immutable. An essential aspect of Python lists is their ability to accommodate multiple data types. For example, within a single list, we can include both strings and numbers, regardless of their type. Creating a list is as simple as placing various comma-separated values within square brackets. The name of the variable is users, and the value assigned to it is a list which contains more than one item. All the data in this list are strings. Python allows us to store different data types in a list. For instance, items equals 9, 2. The second list, which is items, has different data types. The first item is a string, 9 is a number, while 2 is a boolean. Let's use the type function to know the type of the variables. Point type users point items. Let's execute the program. This shows that both of the variables are lists. Sometimes you may need to create an empty list. This can be done by using an open and close square bracket. My list equals print type my list. Let's execute the program. Great. This is an empty list. Another way to achieve this is by using a list function in Python. List underscore a list print type list of a. This is how we can create an empty list. Similar to the string data type, each element in a list has a position known as the index. Indexing in Python, as well as in most programming languages, follows zero-based counting. This implies that the first element in the list has an index of 0, the second element has an index of 1, and so forth. To access an element in a list, we just need to mention the name of the list names, followed by open and close brackets, then the index of the item, in this case index of 0. Let's print the result. The expected output here is early. Let's execute the program and see the result. This is how we can access elements in a list by using the index. Let's do the same thing for other elements. 1, 2. We are able to access the element in the list by using the index. Attempting to use an index that does not exist will result in an index error. Let's use index of 3. Python raised an index error because the index cannot be found. Python supports negative indexing for its sequences. The index -1 corresponds to the last item, -2 to the second to the last item, and so forth. Let's try that out. -1, -2, -3. Let's run the program. Great. To check if an item exists in a list in Python, we use the in keyword. It returns true if the item is present and false otherwise. Here is an example: is present equals 6 in numbers. Print is present. The value from this evaluation is assigned to a new variable called is present. We are making use of the in keyword to check if 6 is in numbers. The result will be false. Let's run the program and see the output. Great. Let's use another number that is present. 2. 2 in numbers, yes. The result will be true. Lists are mutable, which means the items within a list can be modified. Consider a list of numbers equals 5, 6, 7, 8. To modify a specific element, you must know its index within the list. For instance, the index of 6 is 1. We need to mention the name of the list and the index which we want to modify. In this case, 1 equals 9. This operation assigns a value of 9 to the element at index 1. Print numbers. Let's execute the program. Great. By now, the original list has been updated. 6 has been replaced with 9 by making use of the index of 6. If we specify an index that cannot be found, Python raises an index error. The indices present in this list are 0, 1, 2, 3. If we specify 4 which cannot be found, Python raises an index error. Let's execute the program and see. This is an index error. List assignment index out of range. List concatenation involves combining two or more lists to create a new list. To concatenate lists, we make use of the plus operator. Let's declare a variable list underscore a equals 1 plus 4, 5. Print lists underscore a. The result of this operation will be a new list containing all the elements from both lists in the order they are combined. Let's execute the program. Great. This is how we can combine two or more lists to form a new list. The multiplication operator, when used with a list, repeats its element. Here is an example. X equals 1, 2 times 2. Print x. Let's run the program. Great. The elements in the list are repeated. In Python, you can access a section of a list by using the slicing operator. Let's declare a new variable, sliced underscore list equals my list, which is the original list, 2, 5. The first part is the starting position and the second part is the upper bound. This is going to get elements from index 2 to index 5, excluding index 5. 0, 1, 2. This will be the starting position. 2, 3, 4. The expected output is all these elements. Let's print the results. Sliced. Execute the program. Great. If the upper bound is not given, it takes all the items from index 2 to the end of the list. Let's try an example. Print my list 2. In this case, the upper bound is not given. That means it returns all the elements from index 2 to the end. Let's execute the program again. Great. When the starting point is not given, it takes all the elements from index 0. Print my list. The starting point is not given and the upper bound is 4. This is going to return all the elements from index 0 to index 4, but excluding index 4. 0, 1, 2, 3. This will be the results. Let's execute the program. Great. If both the starting point and the upper bound are not given, all the elements in the list are returned. Print my list. The result will be a list containing all the elements. This is because the default starting position is 0 and the default upper bound is the end of the list. Let's execute the program. Great. This returns all the elements in the list. Apart from the starting and upper bounds, the slice operator allows us to specify a third value, which is referred to as the step. Slice list equals my list 1, 2. The starting position is 1. If the upper bound is not given, it returns all elements up to the end of the list. The third number indicates selecting every second element. The expected output here should be starting from the index of 1, 0, 1 and selecting every second element. The second element after 2 is 4. After 4 is 6. After 6 is 8. That means the expected output will be a list containing 2, 4, 6, 8. Let's print out the result. Print slice list. Execute the program. This is how we are able to select every second item in the list. The default value of the step, if it is not given, is 1. We can make use of the slice operator to reverse a list. Reversed list, my list. Print reversed list. The starting position is not given. That means the default will be used, which is 0. The upper bound is omitted, making it return elements up to the end of the list. The negative step indicates that this should be done in a reverse order. Let's execute the program and see the output. We have been able to reverse the original list and store it in another variable. Thank you for watching, and I hope you enjoyed the video. See you in the next video.